So let me introduce our company. It's called CloudBEAR, and we are RISC-V processor IP provider. Our company have different series of products. EM series, which is targeting microcontroller level, and we have 3 cores, which is Linux-capable machine, from the tiny Linux application core ideal for IoT application to the high-end out-of-order CPU, which more target high-performance applications like industrial automation, artificial intelligence, advanced IoT nodes. And we are planning to make during 2019 BR series, which more starting for embedded control, for baseband control, model processing, low latency networking. So I will start from the smallest core, which is called BM310. This is three-stage microcontroller core compatible with ARM M4 in terms of performance, featuring the integrated interrupt controller, debug module, and tightly integrated memory. It's a very tiny total area on 40 nanometer, like 0.05 millimeters. Also, all our cores are supporting the industrial toolchains for the development. So we have own open source based toolchain based Eclipse, OpenSCD, and we also support third-party vendors like Walterbach and Ziegler, and it was tested with all cores which we have, so you can just take the industry-leading products and perform debugging with our IP. So BI series are for Linux-capable machines. So we have different versions which compares with high-end industry cores. Starting from the high-end CPU called BI671, which is compares to the most highest performance MIPS CPU, which currently available from the MIPS. And we have a very tiny core. You can see the demo on our booth. It's actually fits on very tiny silicon area and still can provide you Linux capabilities for your IoT applications. And something in the middle is in order to issue CPU, still high performance, but for more power constrained environments. So all these CPUs have same core plexus features, so it can be integrated together in coherent system via L2 cache. We also support coherency via front port, so your accelerators or peripheral devices can work in tightly coupled with the CPUs and maintaining complete coherence with the processor code, which simplifies your software development. Here is the architecture of our application core, out-of-order core, which achieve 1.5 gigahertz in worst conditional silicon, so it's -40 and TSMC HPC plus, with 1 megabyte L2 cache dual core configuration takes only 4.5 millimeter on your silicon. And here is not many RISC-V designs currently showing the Spec 2004 performance, which is industry recognized benchmark, not only benchmarking your core itself, but also your memory subsystem. And here you see the comparison with well-known high-end MIPS core called P5600, which, as you can see, already RISC-V can be very compatible, and on some benchmarks even higher. And important metric here is GAN-min metric, which showing kind of average. So as you see, completely on the same level already. We already have design win for the customer for this core, for this particular core. And currently, customer integrating into silicon for industrial applications, reaching with various set of peripherals like PCIe cameras, LCD controller, Ethernet, and others. So it was optimized for customer license memory compiler and standard cell libraries. So we provide such design services to the customer, and also we support customer SSD integration right now because it's still a lot of issues is RISC-V in terms of software, and you need, when you're migrating from some ARM systems, you need to work on your peripheral, on your software stack, and that's what we're also doing for them. So simpler core, which is BI651, it's in-order machine, targeting more low power applications. We also showcasing the benchmarking here, comparing to well-known ARM products based on A53, and also Sci-Fi U54 RISC-V core. So also you see it's pretty much competitive on most of the benchmarks, and Kelmin on the right side showing that it's pretty much competitive on the same class level CPU from ARM already. In terms of area which it takes on the silicon, you can compare these different cores with a single issue implementation from the competitive solutions. So you see that on core area, it's only increasing by 35% on out-of-order core. But if you look at the traditional instantiation template where you add a layer 2 cache to your dual core configuration, it's only 16% larger than single issue solution, but while providing 70% more performance in terms of spec and traditional benchmarks like TriStone and Cormark. Our company, so this is a baseline course which I have presented today. It also can be customized for the customer needs, for different interfaces on the SSCs, different tightly coupling with accelerators, or providing the custom instructions. And we also support our customers with SoC integrations of our CPUs in their particular silicons. So thank you for your attention. If you have any questions, welcome.